HydraFACT basically is the abbreviation of Hydrate Flow Assurance, Consulting and Technology. So that's the reason we chose HydraFACT, the name. A bit about my background. I have a BSc in chemical engineering, and then I was university lecturer, the same university, for 3.5 years, and then production engineer, one of the biggest units of production in Iran, 250,000 barrels per day, for 4.5 years. Obviously, I didn't start with that one. I started with a small unit, but final job was that big production unit. Joined Heriot-Watt University in 1991 as an MPhil and PhD student, and then employed by Heriot-Watt University in 1994, and that converted my full-time studentship to part-time, and graduated with PhD in petroleum engineering in 1995. And then lecturer in 1997, reader, which is equivalent to senior lecturer in 2001, and professor 2003. Formed HydraFACT in 2006. In fact, they named the HydraFACT, we bought a company and changed the name. And that company was registered in 2005. One of our biggest achievement, playing a major role in Heriot-Watt winning the Queen Anniversary Award in 2015. Recently, we formed another company, HydraFACT Green Solution. Aim is to focus on green energy and even human health, environment. So we have a sort of aspiration, is we have big aspiration. So HydraFACT as a Heriot-Watt spin-out company. The spin-out company is the company that uses the technique or innovation that originates from university. A spin-out company, university will have a share, but is minority share, 24%. So the company is independent. But why we formed this company was that PVT research started in 1978 at Heriot-Watt with late Professor Ali Danish. And then gas hydrate research also started in 1986. Again, with Professor Danish and Professor Heriot-Watt. I joined, as I say, in 1991. I formed Center for Gas Hydrate Research in 2001 and Center for Flow Assurance Research in 2007. And I should mention, most of our university projects are joint industry projects. And I'm sure you know, PVT pressure, volume, and temperature is that how water and hydrocarbon system behave under different pressure and temperature from reservoir to end user. And also the property, density, interfacial tension, and viscosity. Hydrate, as you probably know, are ice-like components formed as a result of combination of water and suitable size molecule, not necessarily gas, any size molecule at low temperature and normally high pressure that can block pipe. As I said, initially was hydrate and flow assurance and PVT. So HydraFACT was formed in 2006. And why we formed HydraFACT? There was a lot of demand from industry. Because as I said, most of our projects are joint industry project. After a while, people from industry trust you because we had 6 monthly meeting. They trust you and they have problem in their operation. And then they ask you, can you solve it? And they have seen your ability, you say yes, but obviously you cannot charge that project because that project belongs to everybody. So we end up doing one-to-one project. These projects normally are short-term, while JIP are 3 years term. And the reason 3 years because we use JIP to train PhD students. University was not very happy that we spend time on consultancy because university in UK are judged based on the number of paper and number of PhD students. So the best way to move forward was to form a knowledge-based company that uses the technique in university and in a way commercialize. So that was the background forming HydraFACT. Now, HydraFACT in the beginning, obviously, we didn't have staff, we didn't have lab. So university helped us, giving us lab space. So we had a period of incubation, 3 years incubation, and then they kick us out. So what we do? We do flow assurance. Flow assurance means that to make sure uninterrupted and cost-effective production from reservoir to end user. And the area that we cover is we started with hydrate and then wax, asphaltene, salt, emulsion, foam, scale, corrosion. So obviously you can see that naturally when you see an opportunity to grow, you use it. And the other one is PVT and property of reservoir fluid. As I mentioned, what it means. And now we used to work on, well, we still are working on CO2 and H2S. And now we added hydrogen to our portfolio. So, because we have the same experimental equipment, and we can use it for hydrogen as well. We established a H2S lab some 10 years ago. And as you know, the station lab is very dangerous. Not many labs they have H2S facility. And please, over the last 10 years, we never had any incident, but it needs very strict and procedure. And here you see that what we are talking about, this is wax, this is hydrate, this is scale, and this is asphaltene. Now we also have very good predictive model. The reason that our model is superior, and I accept challenge, the reason is that not because we are very clever. The reason is that we are the only software developing company who has access to experimental data. We can generate the data. And every project that we do, that will increase our database. And as I say, it is very accurate. Now, if you look at what happened to the fluid in the reservoir, that's flow assurance, as mentioned. Flow assurance, the aim is to get fluid from reservoir here facility, but finally end user. And you are probably familiar with PVT curve, phase envelope. That phase envelope needs tuning. We can generate experimental data and tune this phase envelope. And then you see that reservoir temperature is constant, but as it leaves the reservoir, goes to the wellbore, the temperature and pressure drop. And then if you have the ability to model accurately the asphaltene phase envelope, wax phase envelope, hydrate phase envelope, soft phase envelope, then you can predict the type of problem that you're going to face. And sometimes being able to predict will make you able to change the production profile. Maybe you can change the production that eliminate one of them. So that's very important to have a good model. Our area of activity is consultancy, training, providing experimental facility to other labs or government or oil company or research institute. So technical advice can be just technical advice. Consultancy can be just technical advice. Just people want our experience and we tell them that if you do this way, it's better. Or sometimes it's necessary to do some experiment. Or we need to do modeling. So our technical advice comes from many years of experience. And experimental, a wide range of equipment, including an H2S lab. and modeling, we claim we have the best software on water hydrocarbon solid. Now we have training as well. Open courses, in-house courses, hands-on and resident courses. Some companies send their staff to be trained by us to work in the lab efficiently. So they come to stay with us for 3 months, 6 months, or to use some software. In-house, if a company needs some training, we can go there to their offices. Open courses, the courses we announce and people register for. So the courses are theoretical, practical, basic to advanced, and various topics. Some of the topics are gas cycle, wax and asphalting, petroleum engineering for other disciplines, production engineering technology. As I said, my background, I spent 4.5 years as a production engineer. I was production engineer myself. PVT and phase behavioral reservoir fluid. Flow assurance course based on case history. We have many case histories. So we introduce a case history and then learn from it. And climate change. This is something I became interested in, and I've done a lot of research, and I'm still learning, but it's good. We also provide, and if it's a course people want related to our area, we have experts ourselves, or we can invite somebody else to teach that course. Experimental facilities. We can build equipment, high pressure, and from -80 to 350. And our customer are university, oil company, and research institution. So these are the 3 areas that we are active. And the other 2 areas is software. And our software, hydrate, wax, asphalting, PVT, and property of reservoir fluid, has been ranked the best by independent evaluation. Available on annual, permanent, individual, or multi-user, and also with a discount for academic version. Academic version is the same, but we don't give them permanent. The reason is that we have the experience, professor or researcher leaving and taking the software with them. And a 30 days trial is always available for only assessment. They cannot do any calculation. They cannot do not any calculation. They cannot do a consulting job. They cannot do publish paper on that. Technology transfer. Being in close link with Heriot-Watt University, we commercialize the idea which has been developed by my own research group at Heriot-Watt. One of the equipment, HydraCheck, monitor hydrate safety margin. For example, If this is hydrate phase boundary of distilled water, and then NaCl, shift the hydrate phase boundary to the left, and then with methanol, different amount of methanol, and you see that depending on the amount of inhibitor and thermodynamic inhibitor or kinetic hydrate inhibitor, we can see the hydrate phase boundary where the hydrate phase boundary is. And we know pipeline condition, then we can say how much is the safety margin. See, here is safety margin. And that what it can do, this device, it can minimize usage of chemical inhibitor. We bring more reliability to hydrate prevention technique, protect the environment, save money, and it can be connected to sort of internet-based prevention. That is this device. Basically, we need a sample of water, and then we measure electrical conductivity and speed of sound. From these two measurements, we can determine two unknowns. And these unknowns are the amount of salt and amount of hydrate inhibitor. So once we know the amount of salt and hydrate inhibitor, and we know the composition of hydrocarbon, we can plot the hydrate phase boundary. And then when we plot the hydrate phase boundary, if it's here, then there is a risk of hydrate formation. If it's here, there is no risk of hydrate formation, but safety margin is very low. So the client can decide on safety margin. Normally, they use 3 to 5 degrees. And this is the software that can be used in those calculations or independently. So hydrate check for monitoring hydrate safety margin. HydraSense is another innovation originated from my research group at Heriot-Watt University. Is for detecting early signs of hydrate formation and estimating its location. You know that hydrate, the gas trap in hydrate is different from the gas in the system. Hydrates like round and large molecules, like IC4, like C3, like H2S. So when hydrates start to form, they will take the gas from gas phase. And therefore, the amount of IC4 and H2S in the gas phase is reduced. Obviously, that depends on the system, but normally this is the case. And the gas is the fastest moving phase, so we can detect it. We detect hydrolysis form. And also, what happened to hydrate? Hydrate density of hydrate is very close to the density of water, so it will drop in the water phase. And that move is slower. If we know the slip velocity, what is the slip velocity? Is the velocity difference between gas and water or liquid. If we know the slip velocity, you can estimate where hydrate is formed. And this also being field trial. Kinetic hydrate inhibitor. Kinetic hydrate inhibitor are chemical that commonly people believe that can prevent hydrate formation for a specific time. We developed a technique that demonstrates some chemical in kinetic hydrate inhibitor behave like thermodynamic inhibitor. And also we can identify different zones. That what we call it crystal growth technique. And now it's becoming industrial practice. It is not only determining the safety margin, how much, whether the inhibitor can be used for that system, it also tells to people who are developing this chemical that where is the weak point, how they should change the chemical structure. We have used this technique and helping a couple of companies to improve their chemical, and now they are a major player for providing this chemical. So it's more than just evaluation of chemical. And also anti-agglomerant evaluation. Normally, industry uses glass viewing cell with a mixing bowl, metal bowl. So rocking cell with a mixing bowl. We develop a technique based on helical tube mixing. The mixing bowl, the weak point is that too conservative. Because you are only relying on gravity. But in the pipeline, in addition to gravity, you have pressure. Or sometimes gravity is not working. But the fact is that you have pressure. You can move the fluid, move hydrate with pressure. And we have developed technique that can simulate the shear force in a pipeline. And we have done many comparative studies. And we can say, okay, if you have this pressure, if this shear rate, your chemical will work. But at least a lot of people may not accept and take the risk, but we determine where is the risk. Another important development by HydraFACT, this one will go with HydraFACT, is kinetic hydrate inhibitor removal, recovery, and reuse. as I explained what is kinetic hydrate inhibitor, but they are polymer. The polymer come out of solution at around 40 degrees. So the water containing chemical hydrate inhibitor can be solidified, KHI can be solidified as hot temperature environment. We have case studies. The pump failing at net pressure suction head, because before pump there is a filter, and that filter will filter the KHI which has been gelled and reduce the intake pressure, and the pump will fail. The other point, these chemicals, a lot of them are cannot be disposed to the environment. So a lot of companies, they use injection well to get rid of this chemical. But you know, every kilometer, temperature on average will increase by 30 degrees. So if the injection well is to the depth of 3,000 meters, temperature would going to be more than 100. So this chemical will come out, and you cannot inject them. Also, previously you cannot use kinetic hydrate inhibitor with MEG. The reason, because MEG is too expensive, and we have MEG regeneration unit, and that unit temperature is above 160. So KHI will come out. And a lot of MEG regeneration units that are using KHI, they have a slip line that take part of the MEG out. So people cannot use KHI with MEG, while KHI is very powerful compared to MEG. 1% KHI can replace 20 to 40% MEG. So the cost of MEG regeneration unit is very high. If you can replace them with some KHI, especially when the water color increases in a reservoir, because the amount of MEG in the produced water or the water in the system is important. If I'm producing only 1,000 barrels of MEG, then I need, for 50% MEG, I need 500 or 30% MEG. But if the water production is 100,000 barrels, then I need 50,000 MEG. So it is ideal to replace MEG. So this can be the solution. Remove the MEG, recover it, and reuse it. Save the environment, improve economy, less capital, and operational costs. Another innovation by HydraFACT is that used not only by HydraFACT, it has experience in university for more than 30 years now, using quartz crystal microbalance. The quartz crystal microbalance is a piezoelectric material. If you apply force on them, they create electricity. If you provide electricity, they create force. It has a resonant frequency, and that resonant frequency is a function of density and viscosity and mass of the quartz. So ideal for detecting solid deposition. And we are using this at in a project on asphalting, and we are finding very interesting results. So these are the some of the technologies that we are transferring to the industry. We are available for transfer. So as I mentioned, we won the Queen's Anniversary Award in 2015. Experimental Science and Innovation for Oil and Gas sector to improve production and reduce contamination. We were able to extend the life of a reservoir by 5 years, reducing methane injection by 28,000 cubic meters per year, and eliminate the need for depropanation. And that was, this is our head of university. And this is Prince Charles, and that's me. And this is the award. So university was very proud to have this award. And I was proud as well. So these are typical what we do at the moment. And I can send this presentation to you, and you can use it and have a look at it when you have time. Some of them, kinetic hydrogen removal, supporting on this hydrogen deployment, hydrate-backed asphalting emulsion forming capability for different reservoir fluid. So these are some of the work we do. A lot of sour gas, H2S. This is wax. For asphalting. PBT capability. PowerPoint, measuring density, viscosity, interfacial tension, measuring composition of various phases, conducting steam tube tests, minimum stability, soiling, forward contact, backward contact, so and thermodynamic modeling.